Have you ever just stopped and wondered how a machine, basically just a box of wires and silicone, can do these incredible, almost magical things? Well, the secret, it isn't in the machine at all. It's actually in how we learn to think. Let's get right into it. So here's what we're going to cover. First, we'll get into the whole mindset of thinking like a computer. Then we'll unpack two really powerful tools, decomposition and abstraction. We'll even put them to the test with a classic navigation problem, and then wrap it all up by seeing how these skills are absolutely essential in the real world.
All right, first things first, let's tackle that big, fundamental question. How do we make a machine actually understand what we want it to do?
I mean, really think about that for a second. Computers don't have intuition. They can't guess what you mean or, read between the lines. So the real puzzle is, how on earth do we translate our messy, complicated human thoughts into a language a machine can understand and follow perfectly every single time? And this is where it gets interesting. The secret isn't about building a smarter computer. It's about us. It's about a kind of human superpower, a way of thinking that lets us organize our ideas so clearly that a computer has no choice but to get it right. And that way of thinking, it has a name, computational thinking. And I really like this definition because it highlights something crucial. We're not trying to become computers. No, we're learning to think like a computer scientist, someone who knows how to break down a problem and line it up so a machine can knock it down. And in that mental toolbox, there are two main tools they use over and over again to make this happen: decomposition and abstraction. So let's open up that toolbox and take a closer look at each one, shall we? So our first tool is decomposition. This is pretty much always your first move when you're facing a problem that feels, well, just too big and messy to even know where to start. The idea is actually super simple, but it's incredibly powerful. You just take a huge, intimidating problem and you chop it up into smaller, much more manageable pieces. You're basically turning a giant challenge into a series of smaller, bite-sized puzzles that you can actually solve. Think about it like this. You wouldn't try to understand how a whole video game console works just by staring at the box, right? You'd decompose it. You'd look at the controller, then the power cord, then the part where the game goes in. Each one is a separate mini problem. And that's decomposition, making something complex way easier to understand just by breaking it apart. Okay, let's grab our second tool and see how it works with the first. Because once you've broken the problem down into pieces, you need a way to filter out all the noise. And that right there is where abstraction comes in. Abstraction is all about being a little ruthless. It's the skill of looking at all the details and then deciding which ones you can completely ignore because they aren't relevant to your goal right now. It's how you find the important stuff in a sea of information so you can actually focus. Let's go back to that game console. To turn it on, do you need to know how the electricity flows from the wall or how the operating system loads up? Of course not. All you need to know is, where's the power button? That simple act of ignoring all the complex stuff happening on the inside just to focus on one simple action? Yep, that's abstraction. Okay, I know these concepts can sound a little, well, abstract. So let's make it real. Let's put these tools to work on a problem we have all definitely faced: trying to follow directions. Oh man, we've all been there, right? You get directions that sound more like a poem than a map. Go past the funny-looking mailbox. What happens if they paint the mailbox? This is a perfect example of a problem that is just crying out for a bit of abstraction. And here it is. This is the magic of abstraction right here on the screen. On the left, you've got the real world with all of its messy, confusing details. But on the right, we've stripped away everything that doesn't actually help us get from A to B. And what's left is a clean, simple, and super effective map. When you have that abstracted map, you get instructions that are practically impossible to mess up. No more tall buildings or trees, just clear, simple steps. By getting rid of all that noise, we've created a solution that is both elegant and pretty much foolproof. And this is so much bigger than just giving better directions. This whole way of thinking, this computational thinking, it's a fundamental skill for living in our modern, tech-heavy world. Just think about all the technology you use every single day. The people who built it, the software engineers, the app developers, even the people who design the hardware, they are masters of this stuff. Their entire job is to take these unbelievably complex systems and, using decomposition and abstraction, make them just work. But let's be super clear about this. This is not just for people who code. At its core, computational thinking is a universal problem-solving kit. It's a structured way to handle any overwhelming challenge, whether that's planning a huge event or launching a new business. So, I'll leave you with a little challenge. Think about some big, messy problem in your own life right now. What do you think would happen if you really applied these two tools? If you broke it down into its smallest parts and then just ignored everything that wasn't absolutely essential? Give it a try. You might find that your next big breakthrough is just a little bit of computational thinking away.